In this video, we're going to be taking a look at the double angle identities. So let's recall the formula of the identity for sine of the sum of two angles. That was sine of the first angle times cosine of the second plus sine of the second angle times cosine of the first angle, like that. So what can we do to determine the identity for sine of 2x? Well, sine of 2x is sine of x plus x, right? And sine of x plus x, I can use both of these as x's. Sine of the first times cosine of the second plus sine of the second times cosine of the first. That is sine x times cosine x plus sine x times cosine x, which is 2 sine x cosine x. So if our two angles are the same, then we can use this identity. What about the identity for cosine of a sum? Cosine of a sum is cosine of the first times cosine of the second minus sine of the first times sine of the second. So what would be the identity for cosine of 2x? Well, cosine of 2x would be cosine of x plus x, which would be cosine of the first times cosine of the second minus sine of the first times sine of the second, and that is cosine squared x minus sine squared x. So those are our identities for the double angles of sine and cosine. So sine of a double angle identity, sine of 2x, if you'd like to call it 2a or 2b or 2 theta, whatever, 2 whatever, this is 2 sine x cosine x. For cosine, cosine of 2 times something, some angle, is cosine squared of that angle minus sine squared of that angle. Okay, these are our last two identities that I need you to memorize. I do need you to memorize these two. Okay, we also use these in calculus, so these are not going anywhere. We tend not to use the sum identities, but these double angle identities come in frequent enough that we need to know them. All right, we do not memorize a separate one for tangent. We just use sine of the double and cosine of the double. All right, let's look at an example. Here I give you that sine of x is negative 3 over 5 and x is in quadrant 4. So here we are in quadrant 4, and here is my angle that they call x. So there's x. Here's the reference angle for x. Sine of x is negative 3 over 5, so negative 3 over 5, opposite over hypotenuse. That makes our adjacent side 4. So sine of x they gave me was negative 3 over 5. Cosine of x will be 4 over 5, adjacent over hypotenuse. And those are the only two things we need for these. So we can go straight. Sine of 2x is 2 sine x cosine x. That is 2 times sine x is negative 3 over 5. Cosine x is 4 over 5. 2 times negative 3 times 4 is a negative 24. 5 times 5 is 25. That's it. Cosine of 2x is cosine squared x minus sine squared x. Cosine squared is 4/5 squared minus sine squared, that's negative 3/5 squared. So this is 16 over 25 minus, we're squaring a negative, so it's going to be a positive, but this minus is still in play. So negative 3/5 squared is 9 over 25. 16 25ths minus 9 25ths is 7 25ths. That's cosine of 2x. So tangent of 2x is sine of 2x divided by cosine of 2x. So that will be negative 24 over 25 divided by 7 over 25. They have a common denominator of 25. I multiply top and bottom by 25, and that's when I get negative 24 over 7. And it doesn't get any harder than that for double angle identities. That's it. So in class today, I think we're going to use today to talk about Calc AB versus Calc BC for next year for students going into calculus next year.